Hi students, I hope you are doing well these days, and in the previous session we have discussed about the trigonometric angles, the ratios of trigonometric angles, sin 60, cos 60, sin 30 degrees, cos 45 degrees, tan 45, cosecant 90. These are all the values we have discussed, and its application part also we have seen. In the today's session we are going to discuss about the trigonometric identities. Trigonometric identities. What are the trigonometric identities? So first, before that, what is an exactly identity? What is an identity exactly? So in the previous sessions, like even class 9th and class 8th, these are all we have discussed about the algebraic chapter. So in that, algebraic expressions and identities. It is an equation involving the variables, which is true for all the values. It is an equation involving the variables, which is true for all the values of the variables which are involving in that expression, in that equation. In that equation is called an identity. Look at this. A plus b whole square. In the previous classes we have discussed about the identities. A plus b whole square. A square plus 2ab plus b square, and a minus b whole square, which is equals to a square minus 2ab plus b square. These are some identities which we have discussed in the some identities. So we have so many identities which we discussed. So here a and b are the variables. For these variables, left hand side and right hand side, the values whatever you put for a and b, it holds, it satisfies the whole equation. Such equations are called identities. A plus b whole square is equals to a square plus 2ab plus b square, and here a minus b whole square is equals to a square minus 2ab plus b square. In this, the a plus b, for a and b, the values which you will input, the values which you give for a and b, the whole equation, both LHS and RHS, both the sides it balance, it is equal, we get the same. If it is, then such equations are called identities. Such equations are called identities. So a plus b whole square is equals to a square plus 2ab plus b square. This is an equation. So similarly these are the algebraic identities. Similarly, we have trigonometric identities. What are those trigonometric identities? What is the definition of trigonometric identity? Trigonometric identity is an equation involving the trigonometric ratios of an angle is called a trigonometric identity. It is true for all the values of the angles involved in it. We are talking about trigonometry. So in trigonometry means the angles. So it is an equation which involving the trigonometric ratios of angles. It may be whatever the angle, trigonometric ratios of angles is called a trigonometric identity. It is true for all the values of the angles involved. In that identity. So it is an equation. First of all, it is an equation. Let us see what are those trigonometric identities. So mainly we have three trigonometric identities. The first one is sin square a plus cos square a is equals to 1. Sin square a plus cos square a is equals to 1. And the second identity we have tan square a plus 1 is equals to secant square a. And the third identity we have, that is cot square a 1 plus cot square a is equals to cosecant square a, or 1 plus cot square a is equals to cosecant square a. Tan square a plus 1 is equal to secant square a. Then sin square a plus cos square a is equals to 1. These are the main three trigonometric identities. main three trigonometric identities. What are these trigonometric identities? How to get? What is this meaning? Sin square A plus cos square A is equals to 1. Sin A, sin of angle A with respect to A, the sine ratio, trigonometric ratio with respect to angle A, sine trigonometric ratio whole square. The A can be any angle. A can be any angle plus cos square A with respect to angle A, the cos trigonometric ratio. A is any angle with respect to these two. A is same, A is same. So for any angle, whatever the value you give, any value you give for the way A, it holds, it satisfies the whole equation. That is an identity. Sin square A plus cos square A is equals to 1. Tan square A plus 1 is equals to secant square A. And 1 plus cot square A is equals to cosecant square A. 1 plus cot square A is equals to cosecant square A. These are the three identities what we have. Let us discuss how these identities we get. Let us say in a triangle. So in a triangle ABC, angle B is equals to 90 degrees. Angle B is equal to 90 degrees. Angle B is equals to 90 degrees. Now let us see the triangle. This is a right angle triangle. With respect to, that is, angle B is 90 degrees and A and C are other two angles which are acute angles. So with respect to B, angle B is 90 degrees, angle A and C are acute angles. Now with respect, look at this carefully. So according to Pythagoras property, we know that hypotenuse square or side square plus side square is equals to side square plus side square is equals to hypotenuse square. Side square plus side square is equals to hypotenuse square. What is the side? We have side BC. We have side BC square plus, you see here, BC square. The side is BC. BC square plus another side is AB square is equals to hypotenuse AC square. So to get the equation 1, what we are doing, dividing. Let this equation as 1. This equation is 1. Dividing equation 1 by AC square. We are dividing the whole equation. When you are dividing the equation, you have to divide both LHS as well as RHS with AC square. We are dividing the whole equation with AC square. Now you see AB square, BC square by AC square plus next AB square by AC square is equals to AC square by AC square. AC square by AC square. Now BC square by AC square, you can observe it clearly. The square is for both numerator and denominator. Square is for both numerator and denominator. We can write the square for both numerator and denominator together. So BC by AC whole square plus AB, here also you see AB by AC whole square is equals to, what can you say about this AC square by AC square, which is nothing but 1. Now BC by AC with respect to A, observe it, with respect to A, we are talking about with respect to A, BC by A, BC by AC, what do you call that is, which trigonometric ratio will come? Opposite by hypotenuse, so with respect to A, now, with respect to angle A, with respect to angle A, with respect to angle A, BC by AC. Observe it, with respect to A, which is the opposite side, that is BC. BC by AC. BC by AC. That means, observe it, BC is the opposite side, by AC is the hypotenuse. BC by AC. What can you write this one? Sin A. Sin A. Observe it, BC by AC. That is sin A. BC by AC, which can be written as, BC by AC. Clearly observe it, BC by AC. Here, BC by AC. BC by AC. AB by AC. That means opposite side by hypotenuse, adjacent side by hypotenuse. Clearly you can BC, that is nothing but sin A whole square plus AB by AC adjacent, that is, so cos A whole square is equals to 1. Cos A whole square is equals to 1. But the sin A whole square, in spite of writing sin A whole square, we write the trigonometric ratio as sin square A. The meaning is sin square A plus cos square A is equals to 1. You see here, the sign of angle A with respect to trigonometric ratio is sin angle A for that whole square. Either you write like this or you write like this. The meaning is same. So the identity sin square A plus cos square A is equals to 1. Sin square A plus cos square A is equals to 1. Suddenly how you got sin square A and cos square A? Opposite by hypotenuse, that is sin. Adjacent by hypotenuse, that is cos. So sin square A plus cos square A is equals to 1. This is the main identity. We got the first identity. Now you see the whole equation. Which is the first equation now? First equation is this. So first equation is BC square plus AB square is equals to AC square. Now if you divide the whole equation with some other, then you will be getting the second identity. So that is second identity is what? Tan square A plus 1 is equals to secant square A. Tan square A plus 1 is equals to secant square A. To prove this, BC square plus AB square is equals to AC square. BC is opposite side. So what I am doing now? Dividing equation 1 by BC square. The whole equation I am dividing with the BC square. Observe it. What is the first equation we have? BC square by BC square plus, the equation is this one, AB square by BC square, which is equals to, now you say, what do you have? That is hypotenuse. AC square by BC. AC square by BC. So instead of dividing with BC, to get the second identity, hypotenuse by adjacent side, hypotenuse, we divide with the AB. So we are dividing the whole equation with the AB. AB square. If we divide the whole equation with the AB, observe it, AB square, though AB square plus BC square by AB square plus AB square by AB square is equals to AC by AB. AC square by AB square. Now you see BC by AB. Observe it here. BC by AB whole square is equals to BC by AB whole square is equals to AB square plus AB square is AB square plus AB square is 1. is equals to, this is 1. The value of this AB by AB is 1. And AC by AB whole square. So with respect to A, observe it, with respect to A, BC is the opposite side. BC is the opposite side and AB is the adjacent side. BC by AB with respect to angle A. BC by AB opposite by adjacent, which is nothing but tan square A. So this is tan A whole square opposite by adjacent plus 1 is equals to AC by AB hypotenuse by adjacent, which is nothing but secant A whole square. So this can be written as tan square A plus 1 is equals to secant square A. Tan square A plus 1 is equals to secant square A. This is the second identity. What we got, tan square A plus 1 is equals to secant square A. Now the third identity. So to get the third identity, now dividing equation 1 by BC square, dividing the whole equation by BC square. The first equation is BC square, so BC by BC square by BC square plus then AB square by BC square is equals to AC square by BC square. Observe it, BC square by BC square, which is nothing but 1 plus AB by BC, right, as AB by BC whole square, which is equals to AC by BC whole square. So 1 plus with respect to with respect to angle A, AB by AC, AB by BC, what do you call? Adjacent by opposite. Adjacent by opposite is nothing but cot. So cot A whole square is equals to AC by BC, hypotenuse by opposite side, which is nothing but cosecant. So cosecant A whole square. So from this you can write 1 plus cot square A is equals to cosecant square A. So these are the main three trigonometric ratios, the trigonometric identities of some angle. A can be any angle. In place of sign A can be 30 degrees, 40 degrees, 60 degrees, 45 degrees, any angle. So which is equals to 1. It satisfies the whole equation. True. Tan square A plus 1 is equals to secant square A. And 1 plus cot square A is equals to cosecant square A. So these are the main three trigonometric identities. I hope you understood how these identities are we are getting by taking a right angle triangle and by applying Pythagoras property. We are getting the trigonometric identities. Is it clear, students? Right. So now, by using those three trigonometric identities, we can even write sin square A plus cos square A is equals to 1. This is the main identity. This is the first identity. So from this, we get the other two identities. We can write as, see, transpose this plus cos square A that side, sin square A is equals to 1. If you transpose 1 minus cos square A, 1 minus cos square A, we are transposing cos that side. Next, similarly, keep cos this side. Cos square A is equals to 1 minus sin square A. 1 minus sin square A. So, from this, the first identity, we are getting the other two identities. Similarly, we have one more, that is main identity. What is the main identity? Tan square A plus 1 is equals to secant square A. Now this is the main identity. From this identity we can write the other identity as like this. So tan square A plus 1 is equal to tan square A. So tan square A is equals to transpose 1 that side, then you will get secant square A minus 1. Secant square A minus 1. Now next identity we can be written as, now keep 1 this side and transpose tan square A that side. Keep 1 this side and transpose tan square A that side. Then you will get, when you transpose tan square A that side, it will be from here secant square A minus 1, secant square A minus 1 is equals to tan square A. We are keeping secant square A minus 1 is equals to tan square A, that we wrote. Now transpose tan square A that side. Secant square A minus tan square A is equals to 1. Secant square A minus tan square A is equals to 1. That is one identity. Next, the third identity what we have, 1 plus cot square A. So 1 plus cot square A is equals to cosecant square A. So this is the third identity. From this we get another identity is transpose cot square A that side, it will be minus cot square A. If you transpose cot square A that side, observe it, if you transpose cot square A that side, cosecant square A, transpose this that side, cosecant square A minus cot square A. So cosecant square A minus cot square A is equals to 1. This is one identity. This is actually third identity, and this is second identity. From that we are getting these identities. Now cosecant square A minus cot square A is equals to 1. We transpose. Now transpose only one that side. Then you will have cot square A is equals to cosecant square A minus 1. Cot square A is equals to cosecant square A minus 1. These are the identities. So three identities. So the last one you see here, the three identities. From this again we get here, I am writing this identity. 1 plus cot square A is equals to cosecant square A. Transpose 1 that side. If you transpose 1 this side, then you will get cot square A is equals to cosecant square A minus 1. These are the identities what we get from three main identities. So we can transpose LHS to RHS, RHS to LHS. So let us discuss some of the examples based on these identities. Example. Suppose sin square 30 degrees plus cos square 30 degrees is equals to what? You see the angle, both the places, sin square A plus cos square A is equals to 1. So A is 30 degrees, 30 degrees. So what is sin 30 value is what? That is 1 by 2. We know sin 30 is equals to solution. So sin 30 degrees is equals to 1 by 2, and cos 30 degrees is equals to, so sin 30 is 1 by 2, cos 30 is root 3 by 2. Cos 30 value is what? Root 3 by 2. Now substitute these values in this. Sine square 30. Sine square 30 means for sine 30 value it is whole square. So 1 by 2 whole square plus root 3 by 2 whole square. So root 3 by 2 whole square, which is equals to 1 by 2 whole square means it will become as 1 by 4 plus 1 square is 1 by 2 square is 4 plus root 3 whole square means 3 by 2 square is nothing but 4. So which can be written as 1 by 4 plus 3 by 4, 1 plus 3, that is 4 by 4, which is equals to 1. Now you see what you got, sine square 30 plus cos square 30. The identity is sine square A plus, observe it, sine square A plus cos square A is equals to 1. So you must get the answer as 1 only. So we got the 1. Therefore sine square 30 degrees, sine square 30 degrees plus cos square 30 degrees is equals to 1. Sine square 30 degrees plus cos square 30 degrees is equals to 1. This is how we apply these identities. Is it clear, students? We have discussed about the trigonometric ratios identities. Trigonometric identities. Is it clear? Now those identities even can be expressed in terms of another, that is, we have the identity sine square A plus cos square A is equals to 1. Just now we discussed sine square A can be written as 1 minus cos square A. Sine square A can be written as 1 minus cos square A. Now sine A is equals to, what can you write sine A? Yes, you are right, that is root of, now here it comes as plus or minus, because it can be plus or minus 1 minus cos square A. 1 minus cos square A. Similarly, observe it. Similarly, you can write from here cos square A is equals to, cos square A is equals to 1 minus sin square A. 1 minus sin square A. Now cos A is equals to plus or minus root of 1 minus sin square A. 1 minus sin square A. Now another identity, by using the another identity, what is another identity we have? 1 plus tan square A plus 1 is equals to, observe it, tan square A plus 1 is equals to secant square A. From this, tan square A is equals to secant square A minus 1. Secant square A minus 1. So tan A is equals to plus or minus root secant square A minus 1. Secant square A minus 1. Similarly we write now. Similarly, secant square A is equals to, observe it, this one. Secant square A is equals to tan square A plus 1 or 1 plus tan square A. Now secant A is equals to plus or minus root tan square A plus 1. Secant A is equals to. Now the third identity we have. The third identity. What is the third identity? That is from third identity. This is from second identity. Okay. And this is from first identity. Third identity we have 1 plus cot square A is equals to cosecant square A. 1 plus cot square A is equals to cosecant square A. So from this you can write cosecant A is equals to root of plus or minus 1 plus cot square A. We can write either plus or minus. Similarly, now transpose from this cot square A. 1, if you transpose that side, cot square A is equals to cosecant square A minus 1, and cot A is equals to plus or minus root of cosecant square A minus 1. Cosecant square A minus 1. These are the identities. From one identity we can derive so many. So here it can be plus or minus. First step is sin square A is equals to 1 minus cos square A. The second one more we are getting, it can be sin A is equals to plus or minus root of 1 minus cos square A. So this is the usage, how we utilize, how we use the identities in different forms. Sin square A plus cos square A is 1. This is the first identity. From this we are getting these identities. Then tan square A plus 1 is equals to secant square A. This is second identity and we are getting like this. We can transpose and we can find out the square root. We can apply these formulas wherever in the application part, in the question solving. We can use any one of these wherever the situation demands. Then we can use such type of identities. So this is about trigonometric identities. I hope you understood today's discussion what we have done in the class, that is trigonometric ratios of identities. So identities. So practice these identities and get ready for the next class. I hope you understood what we have discussed in today's session. Thank you.